In modern art 2, Monet is going to be copying Picasso's paintings. So each one of these paintings is going to be a one-dimensional array of colors of length n. And so there's going to be different layers of rectangles or disjoint intervals of paintings. And the most important thing we can note is that Monet can only paint at most one interval of each color over the entire process. So we want to give the number of rounds so that she paints different disjoint intervals of colors to copy the Picasso painting. Let's go look at the algorithm for this question. We're going to use a stack to solve this question. Before we do anything, we're going to ask ourselves, what do they want? So what is this question asking? And if we look at it, the question is asking the number of rounds Monet needs to paint. And when we paint, since we can paint in disjoint intervals, if we have two different sections that don't overlap, for example this red and this green, then they can be painted in the same round. The only time we cannot paint two intervals in the same round is if they overlap. So the question is essentially asking us, what is the maximum amount of paints or paint intervals that overlap at the same time? So for this specific example here, we have these two overlapping, these two, and the answer to this would be 3, since right here we have 3 different paint colors overlapping. So we're going to use a stack in order to solve this question. And the way we're going to do that is, when we read in our input, we're going to first find the beginning and end of every interval. Since we can only paint every color once, then we're going to see the beginning of every color and the end of every color. So if we look at the test case example here, that's basically going to be for the color 1, it's just going to be 1 and then 4. For the color 4, it's going to be 2, 2, 5, 3, 3, and then for 3, it's going to be 5, 6. And then when we have these intervals, we're going to loop through them, and we're going to push them into the stack every time we reach the starting index, and then pop them from the stack every time we reach the ending index. The answer to this question is going to be the number of layers that are in the stack at the same time. So as long as we push when they start and we pop when they end, if we have something overlapping, like the orange and the red, then we're going to have this pushed, and then before we pop this, in the stack there are currently 2 elements. And then for example for this, it'll be this push, this push, this push, and then before we pop here, there'll be 3 elements in the stack. So our answer is just going to be the maximum amount of values in the stack at the same time, since that's going to represent the most amount of overlapping paint layers. And then the final part of the question before we can code is there are also some instances where it's not going to be valid. And so we're going to have to ask ourselves when or what counts as valid. And if we kind of look at it as a one-dimensional line with just a color on every grid, if we have something like the red and the orange overlapping, where this completely covers this, or in this case actually this one covers this, it's fine. However, if we have something like this dark blue here, where we have red and then blue and then red and then blue again, that's not going to work, since we know that we can only paint one interval of every color, and in order to reach a place where I would have red overlap in between, then we would have to paint more than one intervals. And so what that basically means is, if I've come up with a place where I see a different color that isn't the current color that I'm in, and this color has already appeared before, then it's going to be invalid. When we code this, we're going to keep our set, and for every current grid or value we're on, we're going to check to see if the top of the stack, or the most recent color that we pushed, is equal to my current color. And this is going to work because if we have, for example, this red and then this orange, we push it in and then we pop it. So the next time we see this red again, the red is still going to be on top. However, if I were to do this red, and then I was to start with this blue, and then before this blue ends, since the ending is over here, we're going to see this red, and it's still going to be inside of the stack. And once we reach this blue, we're going to see that the top color is not the current color. So if we have something where it's an overlap like this, we have this, the top is still, let's say this is thread 1, this is 2. So the top value is going to be 1, and then here we're going to push 2. And then here it's still 2, 1, 2, 1, and then here we're actually going to pop the 2. So it's going to be equal to 1, 1, and then we pop the 1, so it's empty. Meaning that if we have an overlap like this, by the time we reach another part of segment 1, the 2 has already been popped out, so the top of the stack is still going to be part of 1. So it's not going to run an error. But if we have something that's like this red and then this blue, where we have something like this, and then we have this, well, we have 1 and we have 2, and we're going to have 1 and then 2. And then since we pre-calculated where the start and end is, we know that the end of 2 is here. Meaning once we get here and we reach here, the top of the stack is still going to be 2. So the top of the stack is going to keep track of whether or not it's valid. If it's invalid, then for example here, the value at the top of the stack is not going to be equal to the current color we're on. But as long as it is valid, the top of the stack is always going to be equal to the current color we're on. Since if we have something inside, it's going to have popped before we reach another element of this color, and any other overlaps would still have our current element at the top of the stack. We're going to start off by reading the input. We're going to keep a vector of the actual values called color, and that's just going to store our input. And then we're going to store the beginning and end of every range using a map of pairs. So this color range is going to store that, and we're going to loop through and read in every value. And we're going to, for every value, check to see if it's equal to 0. And since 0 isn't a valid color, we're just going to continue. Otherwise, we're going to assign the value of color range. So if this current color of valid is already in color range, it means that it's not the beginning element. And so we're just going to assign it to the end of the range. That way, the biggest element is going to be assigned to the end of the range. Otherwise, we're going to create a new value, and the start is going to be equal to our current index. So using this map, we're effectively going to be able to store the beginning and the end of every range, since this is going to continuously update until it becomes the biggest value. And this one is just going to create a new element or create a new value where the starting index is going to be our current I. We're then going to create a stack called painted, which is just going to be our stack while we loop through. And so we're going to check 3 different scenarios inside of our stack. If the new color or the current color we are matches with the top, then that means that we are going to push it in. So if this is the start of a new range, we're going to push it in. And we're going to check our answer, and our answer is just going to be the maximum of the number currently in the stack or the maximum depth. So every time we push a new value in, we're going to check to see if the current size of the stack is the greatest. And then we're going to check to see if the new color does not match with the top. And so this is what we were talking about earlier, where with painted.top, if it's not equal to the current color, that means something is in there that hasn't been popped, and it means that this is an invalid range. So we're just going to output -1. Otherwise, the only other scenario we have that we need to address is if this is the end of a color. And if it is, then we're just going to pop the value. At the very end, we can just output our answer, and that's the end of our program.